Hello and welcome once again to Concepts. In this video, I'll be discussing about periodic and non-periodic signals. At the outset, let me explain that signals are also referred to as waveforms or even as functions. So signals, waveforms or functions, they all mean the same thing, and in this video and maybe in my other videos as well, I'll be using these terms quite interchangeably, but they mean the same thing, and wherever there is some subtle difference I would indicate so, but in general signals, waveforms and functions all indicate the same thing. So when we say a signal or a waveform or a function, we have the independent variable, which is usually the time plotted along the x-axis, and then we have the dependent variable, which is the variation in the amplitude, which is plotted along the y-axis, and we call it as the function of time, which we have denoted here as x of t. So I've shown in these figures here some examples of periodic signals. So what we have here are periodic signals, and I've shown 4 examples in this video here. First of all, what do we mean by a periodic signal? In a periodic signal, we will notice a pattern that repeats itself at regular intervals of time. So a pattern that repeats itself at regular intervals of time. So if you look at these 4 signals or waveforms that are shown here, so we see that this pattern, the waveform starts from this point and it completes one cycle, and then this pattern repeats itself over here, and then there is a second repetition here, and so on. And if we continue drawing, so this pattern here repeats itself. So this waveform or this signal is said to be periodic. Similarly, if you look at this second waveform, which is having a triangular shape, so it starts from here, goes to a peak, comes back to 0, a negative peak, and back to 0. So that completes one pattern, and that pattern recurs and repeats itself for a second time and for a third time, and so on. So similarly here we have this pattern which repeats itself again for a second time here and a third time here, and so on. And in this last figure at the bottom, so the pattern starts over here and ends over here, and that same structure or pattern repeats for a second time and a third time, and so on. So a periodic signal or waveform is a signal that has a recurring pattern that repeats itself at regular intervals of time. Now the time over which the pattern completes one cycle, for example, so the waveform or signal starts here and completes one pattern over here, so that time interval over which it has completed one cycle is said to be its time period. So the time period, depending on the starting point, we can say this is the time period, or if we had this to be the starting point, then the time period would be from here to here. So after which the same pattern repeats. So we have the pattern says, we say if it starts from here and it completes here, and after this the same pattern repeats itself. So in general, a periodic signal is something which has a recurring pattern. A periodic signal is characterized by 2 parameters which are related to each other. So let's write it's characterized by two parameters and these two parameters are related to each other. So if we know one parameter, we could calculate the other parameter. So the first parameter is the time period. So the time period is the duration over which the recurring pattern completes one cycle. Duration over which the pattern completes one cycle. And we represent that by the letter capital T. So for example, in the second waveform we can say that the duration from here to here is one period. So from here to here could be considered as one period, or we can also say that the duration from here to here, so this interval is also one period, and so on. Similarly, for the last waveform, or for the third waveform, we can say this is one period, and after that the same structure repeats itself. So that's the second period, and that's the third period, and so on. And for the last waveform, we could have the period from starting from here and ending here. So that's one period, and after that the same pattern repeats. So it starts from here and goes till here. So that's the second cycle, and so on. So this duration over which the pattern completes one cycle is called as the time period, denoted by the letter capital T. A related parameter which characterizes a periodic waveform or signal is the frequency of the signal. Frequency, and it is usually denoted by the letter small f. The relationship between time period and frequency is that they are inversely related. That is, the frequency f is equal to the inverse of the time period. So frequency tells us the number of cycles or the number of times the pattern repeats itself in 1 second. So frequency is number of cycles completed in 1 second, and it has a unit as hertz, abbreviated as Hz. So if we say that a waveform has a frequency of 1 Hz, that means it completes one cycle in 1 second. If it is 10 Hz, it means it completes 10 cycles in 1 second. Next we come to non-periodic signals. So I've shown a couple of non-periodic signals in the figures here. So these are non-periodic signals. Non-periodic signals are also referred to as aperiodic signals. aperiodic signals. So non-periodic and aperiodic mean the same thing. So in the case of aperiodic signals, there is no recurring pattern. So the first thing is there is no recurring pattern in the signal. So if there is no recurring pattern, what can we say about the time period? Since the pattern does not repeat itself after any interval of time, so we say the time period t approaches infinity. That means the pattern extends from the start till infinity, and maybe after infinity it repeats itself. So in general, we say for a non-periodic or aperiodic signal, the time period t approaches infinity. So if you look at these two examples here, we see that we notice that there is no recurring pattern that repeats itself. So the signal seems to be changing with time, but there is no recurring pattern anywhere in the signal. Similarly here, if you look at this, there is no recurring pattern that recurs at regular intervals of time. So in both the cases, we say that the time period approaches infinity. So for an aperiodic signal, we do not have the concept of a definitive frequency.